Welcome back everybody. In this video we're going to cover C#9 changes. Timestamps are going to be in the description, so in case you want to bounce about and see the actual contents of the video, you can go ahead and look at those. But let's dig in, and the first thing that we're going to take a look at is top level statements, where essentially the change is that the contents of your main function, the static main function, which is the entry point to your application, it can be really overloaded in different ways as well. We're not covering that bit. Primarily what we're covering is that the contents are now sort of flattened out into the top level of your file, right? So the contents that we have here, the console right line, is really the contents of the main, and the args is just a main, what's called a magic parameter available to us anywhere within the file as well, okay? So moving away from the top level statements, two things we're going to cover is the new expression, or rather target type new expression, and the init property modifiers before we move into records, because I use those two features there pretty heavily so we don't get confused what we're looking at. The target type new expression, if we take a look at the syntax here, essentially provides you with three convenient options. Is if you have some kind of a type to which you want to assign, or some kind of type that you want to pass into as a variable into a function, or some kind of type that you want to return, you no longer need to specify what type it is that you are returning, passing as a variable, or assigning if you already know the type on that end. C# will be able to automatically figure out what type it is that you want to create, and I mean, you just use the constructor as you would. So remember, just three situations: when you're assigning and you already know the type, when you're passing it as an argument to a function, and when you're returning it as a result from a method or a function. Okay, so pretty simple, nice short syntax there. So init property only modifier. So if we take a look at this, so we define a class bar, we have a property name, and we specify that it's init only. So the setter is init only. Before, if you wanted your object immutable, you would have to do something like a private setter, and you only set it during a construction, or sorry, only during the construction of the object. And every time you wanted a new object, you would have to go and call the constructor, and your constructor would grow quite significantly. Well, here now that can be sort of brought outside of your function, or outside of your constructor, but however still be only initialize only. So we only set the variable, and then we can no longer override it later in our application. Okay, so this concept primarily will be quite important to understand records and what they are. So moving on to records, let me open up the file here. At the top here, primarily what I want you to understand about records is semantically how you want to think about them is their immutable values, okay? And that's pretty much it, an immutable value. Even though that really they're still reference types, you don't really need to think about it that way, because you use them as values and as immutable values. So let's go ahead and take a look at this definition, and hopefully we'll just, if you haven't taken a look at C#9 yet, you can understand records really simply right now. So if we take a look at the record here that I've created, stuff, and the public class, so stuff class, they look exactly the same. Even records, we can still define something like public bool do. We can still define functions, methods on the record. So what is the primary difference, or how can we see this difference between the record and the class? So what I've actually done here, when I defined the record in this way, I have manually opted into mutability. If you take a look at this previous example where we have to opt into immutability, so initialize only, here the records, when we really define records, we by default request the initialize only properties. So these are immutable. So once you set the value, that's it, they're set, you cannot change them. Here we're manually opting into having this name property be mutable. So this is not really what you want to be doing with record types. You want to be using them as values. But this is just so you understand. So you can opt in into mutability, but the preferred way is still declaring them this way, where the real definition is kind of like having a class with an init only property of name. Okay, so this is how they reflect depending on how you initialize or define these records. Okay, so let's go ahead and move on to an example where we understand that record is a value. So let me go ahead and run this code, and then we're going to take a look through what is actually going on. So there's a couple of results. So what are we actually looking at? So what I did is I defined two stuff classes. So both of these are records where I can change the name. Both of the names are set to A, okay? So here's what you see printed in the console. Stuff A and stuff A are equal, right? When I do that for the stuff class, so this class, which is almost essentially the same, again, I just define a new stuff class. So you can see this new expression type. We essentially do the same. We set A to name and A to name, and because the equality here compares the reference types, so the things that are pointing to the object in memory, this object and this object are contained in two different places in memory, so the reference types are different, okay? However, here, the reference types for the records are still pointing to two places in memory. For the records though, under the cover, what C# does is it creates equality comparers that do it based on the value. So even though we're pointing to two different places in memory, as long as the two values in there are the same, when we compare the two values, they are going to be identical. So here's where we compare the stuff A and A, it's true. When we go ahead and later change it to B and we compare the two, it's going to be false. And here you can see even it just outputs the name of the class, because really what we're doing here is we're comparing the two references. So the two pointers with records, we're comparing the actual memory that the pointers are pointing to, okay? And that is why you need to think of records as values rather than reference types, okay? So let's uncomment that. Move on to the next point where we understand that records are immutable by default, right? Let's forget to rename that. Let's go ahead and run that and let's take a look, right? So here I create a thing, and this is again just to also take a look at how inheritance works with records. We create a thing, and then if we want to inherit, for example, like a mammal inherits from a thing, so usually we can name a thing, so it's no longer a thing. Everything is a thing, but once we give it a name, it's like a different thing, but whatever, right? We go ahead and pass the name to the thing, right? So it's like a single parameter constructor. Again, we have a base single parameter construction, and for the mammal 2-parameter construction, we're passing one of the parameters to the thing, okay? And that's how inheritance works as well. So mammal is going to have a name and a gender. So first of all, records are immutable. We create a thing. If we want to go ahead and change the thing 1, so the name, we get the same error as we would when we are trying to change the initialization only property. So that's essentially what that is. As how do we actually change records? So how do we change values? We need to use the with expression. So thing 1 with name equals bar. So we're essentially saying, give us a record 1, so thing 1, so whatever this record is, give us that where the name is this thing, right? So what this will do is it will create the copy of the object in memory with a different name value. And the same thing will happen on this line. And again, the two outputs that you are seeing here, so we have thing 1, which is foo, thing 2, which is bar, the first time we compare them here. So foo and bar are false. And then we have a copy of thing 3 from thing 2. Right, where from bar, again, we're changing back to foo. So thing 3 and thing 1, again, they're different pointers to different objects in memory, different references if you don't understand pointers. But nevertheless, we're still comparing the thing in memory, so the actual value. So in the end, it is still going to be true, okay? And the last bit that records add that classes don't really have, and you have to implement this manually, is positional deconstruction. So for the, I'll just run this so we can take a look at the console and narrate it. We have a mammal. Again, we just initialize it with foo bar. So foo is the name, bar is the gender. Once we go ahead and try to deconstruct it, right? So into a tuple, name, gender, and there we go. So we can output foo and bar, right? So these are positional. How we define them in the constructor, they get deconstructed in the same order. You can use the deconstruct function that's provided or is generated by C# on the mammal, right? So these deconstruct functions, you can still define them on the classes themselves. So public deconstruct outvar or outvar name, or name equals name. And there you go. So once we go and try to use this class, so let's go ahead and try to put it somewhere here. Outvar name equals Bob, or Bob. Okay, and that is where we deconstruct the Bob, and we can actually. So in case you didn't know that C# had deconstructors, and you can do those through classes. Where did I? And we need more than one, so I mean, we're not in a hurry. Let's go ahead and I don't know, put something like age here, and age equals 5, right? So there we go. Let's come back here, grab the age here. Oh, I can also pop it here. Right. Go ahead and run this. And there we go. So deconstruction, in case you didn't know, it's nothing new. It's essentially something that is generated for records. So remember 3 things about records. Default immutability, so they're using the initialize property that the class is using. And then we have value type comparison, so they're overloading equality comparison, and I guess they are doing it efficiently. I don't actually know how they do it under the hood, but understand that they are comparing the values in memory rather than the references that are pointing. And then the third thing that you get is positional deconstruction, right? So the deconstruction method that we defined here, it automatically gets generated for whatever properties that you have specified in the constructor of the record. Okay, and obviously you can discard these if you want, and these are still the features that are available here, right? So nevertheless, that is pretty much about records, right? Not too much. If you're wondering about the use cases of records, just a second, I have an error here just so I don't trip up later on. Yeah, if you're wondering about use cases of records, where you're usually stuck with sort of 3 ways that you can define classes, kind of templates for data, then you can have essentially just collections of functions where they're data processing, and then you have hybrids. When I generally use these, I try to stay away from hybrids, so just data and functionality mixed together. I try to have classes that are data definitions and the classes that are collections of functions. So I would have some kind of context, and I would put my variables in that context and perform some kind of operation on those values. So for me, it's really collection of functionalities, and records will be replacing that data class that I would constantly be creating, either when I'm using entity framework and I'm just defining how my table looks. That's the sort of thing. The thing that just the value that I'm passing around, it's stupid, it doesn't have any functionality. That's what I'm going to be using the record for, and that will be my primary use case. If you have any other ideas, pop in the comments. I would like to hear that. So next thing is pattern matching. So this is going to be a little bit awkward to walk through. Specifically, let's take a look at this thing first. Because there's so much here, and I couldn't give it really any specific order. So we're just going to look through some examples, and we're just going to understand and get a feel for what pattern matching is and how we can use it, okay? So pattern matching, some of the features here are not C#9 only. Pattern matching has been introduced in C#7 and has been growing since. Some of these are C#9 features, some of these are C#8, some of these are C#7, right? But just as a general overview at the state where pattern matching is right now, let's go ahead and take a look at it. So we go ahead and pass some kind of a type. We go ahead and match it on the type, right? Is it a string? Is it an integer? Is it a long? If you don't know about switch expressions with pattern matching, you gotta have the constant value on when you're matching against a pattern. Okay, when you're using pattern matching, only constants, all right? And you will see an example of where we can mix conditional statements with pattern matching and Boolean expressions. And if you're confused about what an expression is, it's something that can be evaluated to a value. So we look at an expression, 1 plus 1, we evaluate it to a 2, okay? So type comparison, that's something that we can do. Human readable time format, so a function that I like kind of mocked up. Let's take a look at it. We have some kind of date that we're passing in. We take the now, we subtract it, so we get now minus whatever previous date we had. And then we extract the days, the hours, the minutes, the seconds. We then put them positionally in a tuple, so days, hours, minutes, seconds. And then we go ahead and try to compare the values in the different positions. So here I am basically saying, is the day equal to 1? That means it's been yesterday. If it's more than 0, because we already matched the 1, and we haven't matched it, so it must be 2, 3, or whatever. If it's more than 0, then however many days ago, right? And you can see how positionally we are really succinctly, I just realized these look a little bit like duck heads, but can't stop seeing it now, conveniently just checking in which position we want to pattern match, right? So again, it's pattern matching because we're using constant values here, and we would be able to do something like or rather, let's say, and less than 4. Right, so if it's in that range, that's where it's going to match, right? So we can use the and or pattern matching operators, or even like the not, right? So it's going to get a little bit confusing. Just understand there are 4 operators: is, not, and, or. Okay, 4 of those, and you're just going to see them get used throughout these samples. Next thing, type matching, kind of how we had here, where we had a string int long. Where again we're just getting some type and we're saying is string or int or long. I mean, this if you ever used Python, I mean that's pretty much it. Although in Python you have instance of whatever. Is string or long or int, a really nice little, if you want to say, is this a type that I can support or whatever. Next thing is kind of doing ranges. So age, is it more than 20 or less than 49? And again, pattern matching is not general Boolean expressions. If you're looking at this and you're going to be like, oh, this is a very nice example where, let's say, we have a lower bound where we would have 20, and then we will have an upper bound where we will have our 49, right? If these are not constant values, we cannot just go ahead and place variables here. Okay, these are like pattern matching are efficient operations that are performed on these values. So you need them constant when you're defining patterns. So again, you can kind of do ranges. You can take this, to, I mean, a little bit of a higher level. You can put parentheses as kind of to maybe increase readability a little bit, or like your intent of which operations you want to perform first. But my IDE doesn't currently mark these as redundant, but just understand that they are, because and takes precedence before or. So and evaluates first and then the or does. Okay, so let's take a look a little bit about how we can manipulate or do this with objects, right? So for example, here we have a dog, right? We have a name and age, and how we would check that a dog is at null, and then we go ahead and check its age, right? This time we are doing it in a little bit more, if you know SQL, a little bit more declaratively, right? So here we're saying dog is an object where age is bigger than 0, right? So this notation might be a little bit weird to look at, at first, but trust me, once you get used to it, it is actually better than this one. So the is in this case actually checks for null as well, right? So just a way to positionally check dog, right? So dog, here we have the name, the age, and here we essentially can check the tuple of the record, right? So the name, the age, is dog essentially this, or is dog essentially this? Otherwise we can match it. Again, if we want to nest into object within the object, we can. So for example, dog is an object where the name is a length, has a length of 0. All right, so I guess the example is not really correct. It will be something like this. If we want more than 0, we would have to do, say something, I'm putting it in all the wrong places, but we would have to put the duck face in there, right? Next thing is a variable assign. Again, I think this is C#8 feature, but we can. This is how we can mix pattern matching and Boolean expressions. You can see this is no longer a constant. So this kind of definition of dog is an object that has a name, where we then take the name and we go ahead and use it as a variable in the Boolean expression here. Right, so we're combining pattern matching with a Boolean expression where we are extracting that value and putting it there. So there is still potential for that as well. Next thing is a good boy. I mean, just kind of taking it further, where how all of this can get used. So the object is not null, so it's not a null, and it's an object. So I mean, these are kind of a little bit redundant. It's the same thing, and if I would be doing O is dog, it would already take care of both of these conditions, really. I'm just, you know, making ridiculous examples, just kind of gain a little bit more understanding about this. So then we have O, where we say, is basically O a dog that's an object that has a name with a length of more than 5 and less than 10, right? So is the name in range of 5 and 10 for the dog? You may be trying to do maybe something a little bit like this. So just looking at a little bit of gotchas. We have an object O is a dog where the name is Rex or age is 5, right? So it's an object where the property is name Rex or has a property of age of 5, right? So just a little bit getting used to where you will have to say O is an object dog where the name is Rex, or is an object dog where age is more than 5, okay? Should put it back, otherwise I get an error. Right, anyway, switch expressions. So we get a dog, so it's kind of, it's already a dog object from the start here, so we can do tuple comparison. And this is just to, again, explain some gotchas. When we have an object, it's still syntactically correct to give these tuples, but actually, I mean, I wrote up a couple of examples here that hopefully it's not that big of a problem to actually go and write these. So C# go BR, the first bit here is when we supply the dog. C# go BR object, right, is when we actually pass an object to it. So it's kind of just to understand that when you pass an object, it's not necessarily going to be automatically deconstructed to a tuple. A tuple is an object as well. So let's go ahead and give this a run, and we're just going to take a look at the results and what it brings us, right? So here we go. So for the first one, we pass in a dog into the parameter, into the method that accepts the dog parameter. The other ones is the object one. So in the first one, we pass the dog. In the second one, we actually pass a tuple. And the dog object tuple that we're trying to use is foo and to. Okay, so the real first thing is what actually matches, is where the beginning of the tuple is foo. So for the first part where we pass the dog, that matches and we exit. Okay, some of the other ones, again, we just try to match by the age. If a name isn't foo, we then try to match the name and the age, and then we check if it's a dog object with the following attributes. We can then check if the name is bar or baz. We can then check if the name is foobar or age is over 100. You know, there are really multitude of ways that you can take this. Then with the other one, C# go BR object, when we pass in the dog, it doesn't automatically get deconstructed into a tuple when you check for a tuple, so be careful of that. And otherwise, when you have to check against an object, because it is kind of like a generic object, you want to actually specify what kind of object are you checking against. Is it a dog? Is it a cat? Is it a human? Whatever, right? And yeah, just make sure that you're not cut out here. And again, kind of only matching this property when we pass in a dog. When we pass in tuple after, again, this first one gets matched. Okay, so that's pretty much it for the pattern matching. If you were sitting there and you're like, what? Essentially, the thing to take away is the way that you check if a value is something. So if you're checking for a condition, it is slowly becoming a little bit more succinct and easier to do so, right? And a little bit more declarative and performant. Oh, everything's always performant, right? Covariant results sounds fancy, not that really fancy. I don't have a better name for it, so covariant type. Essentially, imagine we have a line and we provide some kind of length to it, right? So again, it's a record. It has a property of length, and then we put a function on it, which we say elongate, which is going to give us a new line where we increase the length. I know we can do it with the width expression. This is not what this is about. This is about when we declare a square and we say that it inherits from the line, when we override the elongate function, it also returns a square. Okay, so this is what this bit is about. If we... I can't believe I closed the link pad examples. Just bring this up real quick. All right, so on .NET 3.1, this is where I'm using C# 8. If you see, if we have a class of line and then we have a square where we try to, again, same override the elongate function where we have a line to return a square, it doesn't work. So we cannot do this, right? It's not something that was possible. Now, again, if we take it further and we have a cube and we try to override elongate or widen or, you know, go further and declare some other virtual functions that we want to overwrite, we can again make sure that the method that is specified on the child type to return the child type, if a parent defines a method that returns a method type, so in our case the parent is line and it returns line, if all the way down the line we have an actual child type that decides to implement that method, we can actually make it return that child type instead of being forced to the parent type. Okay, and that's pretty much it for the covariant results. So native sized integer, a little bit of new syntax. There is not that much to say unless you are concerned with developing for different platforms. So just to give you an example, I think the way that this would work, if you would have a 32-bit platform compared to a 64-bit platform, once compiled for both of these, the native integer type would be different. So for example, for the 32-bit, it would be something like int max value, and for a 64-bit, it would actually be a long max value, right? So the size of it would change. I guess this would be more performant. As a backend developer that's not really that considered with performance, but rather code safety, I don't see myself using this all that often. Unless somebody basically goes around and says, you want to be using a native integer. I'm like, why? And he will explain to me, and then I'll be like, okay. And that will be the end of that. I'll be using native integer for a compelling reason. So static anonymous functions, they just make sure that you are not using the scope, right? So whatever closures you had, that's no longer going to be a thing. So if you imagine we have a field or a property on a class that is not static, so it is only present there when the class is initialized, we can no longer use this inside the lambda, right? So if we remove static, probably want to assign this. So I'll do something like that, right? So this will essentially box it up into a closure and build a separate object and get passed into that. If we make static, that is being forbidden. So if you need to enforce that rule, you can. I think this is the way forward. you don't want to be passing outside scope into the function, right? So lambda discard parameters. I thought this was already in the language. I guess not to the extent that you can do it now. You declare a function, you can discard parameter, you can discard multiple parameters. You can discard 1, 2, 3, however many parameters you want to discard. I mean, lambda discards your oyster, you know. Local function attributes. Again, I'm not big on putting attributes everywhere or developing these, so I'm not that concerned with it. You have some kind of attribute, you can put it on a function that's inside another function. So local function is when you declare a function inside another function, okay? And kind of call it here. It doesn't really matter where you put it, in case you don't know the syntax, but that's essentially it. You can actually now put an attribute on it where before you couldn't, so that's the change there. Module initialization, right? So let me actually comment out the appropriate amount. You would usually see this in test frameworks. One-time setup, I think NUnit is the thing that has it. So one-time setup, one-time teardown at the end. This is for your class library. You create a class library where you want to maybe do some kind of one-time initialization, read the assembly for a specific type of an interface, load them into a cache so you get performance. I don't know if you're like maybe entity framework and you want to read all the expressions of all the queries that are being potentially used and pre-compile them or whatever. You know, basically now you have a place to put that logic in instead of maybe, I don't know how this problem was solved before, but maybe a static constructor or something like that. So extension, GetEnumerator support for each loop, right? So what would happen before? Maybe you can get a type from some kind of library, so you are not the one who implemented it. So you would get foo, somebody gives you foo, and you're like, right, I want to implement a for loop for this, or it seems like a for loop would be really good here. Before you couldn't, now you can. You basically make a extension for the foo class that basically returns the GetEnumerator, and then you basically have your enumerator there. So you obviously implement it if you need to, and once you have the foo, you can actually loop through it, right? So that's that. Partial class method extension. So partial class A defines the method or declares it. Somebody gives you a library where you have a partial class with A, and it will have just a declaration, and then you will have to supply your own definition, right? So you actually implement it here and you declare it here. All right, so that's something that you can have now. I never use partial classes, so, you know, not that bothered. Now, function pointers. Quite a cool feature. So you get a new little bit of syntax here. So for example, we have a delegate or an action or just a method, a function really, because it returns one parameter, but whatever. Add function, we take parameter A, B, we return another integer. So the way that you define a function pointer is you say delegate star and then the signature, which is really kind of like if you would have func, you would have int, and int, right? So you would have something like this, which is a really familiar syntax. You do have to mark the context unsafe, and you use it really almost the same where you have a pointer. So you get an address of your add, or you can store it in a variable, right? And you have a pointer, and you can use that in whatever ways. I'm not a C or C++ programmer. I do not meddle with function pointers. I kind of understand what they are. Just as a bit of a laugh, I ran a benchmark on this, and this is kind of like what happened. So I guess the pointer is a lot more performant. So I have the what's called the function again, kind of the same replication of the example. Here I'm using the delegate. So I just pass the add into do, where I have this one, where I pass the delegate and I call the function. And here I have the pointer, okay? And I pass this thing here. So do add with the address, and it uses this function. If you're wondering for the primary difference, when I actually go ahead and put the code into LinkPad and I take a look at the intermediate language that is emitted, it is a difference in an opcode. I am not that low level of a programmer where I understand what the opcodes mean and what the difference in them is. But apparently, again, we can take a look at this. It has quite a drastic performance improvement, although, again, I'm not sure why. Nevertheless, this will be it for this overview. If you enjoyed it, leave a like, subscribe. If you have any questions, leave them in the comment. If you have any judgments you want to pass, feel free to also leave them in the comments. Join my Discord channel if you want to be part of the community, and hopefully I'll see you in my other videos.